there's something wrong with the universe, and its meaning remains uncertain. The James Webb Telescope has uncovered galaxies that theoretically existed before the Big Bang, challenging the Big Bang theory and our entire cosmology. Science is grappling with a seemingly unsolvable problem, although researchers like Fritz Zwicky had alternative explanations for our universe a century ago. These ideas are becoming relevant again. Few school children today recognize Fritz Zwicky's name, but we know Albert Einstein, Georges Lemaître, and Edwin Hubble. These researchers' theories have shaped our cosmology for almost 100 years. Einstein described space-time, Lemaître proposed the Big Bang, and Hubble observed the universe's expansion. Now, all these theories are being tested, largely due to the new superstar of telescopes, the James Webb Space Telescope. This technological marvel has provided us with captivating images of a previously unknown universe, revealing that old theories are either wrong or incomplete. Fritz Zwicky, a contemporary of these prominent researchers, also studied galaxy movement and cosmic dynamics. His theory, once again relevant and debated today, is the idea of tired light. Zwicky proposed that light isn't constant as Einstein suggested, but undergoes a physical change, or fatigue, during its journey through time and space. Einstein maintained that nothing travels faster than light and that its speed is always constant, unlike other forces in the universe. It's logical that researchers have long used light and its speed as key benchmarks for exploring the universe and measuring crucial values like distances and the rate of expansion. Before we explore potential flaws in these theories, let's examine some of the incredible galaxies discovered by the Webb telescope, galaxies that seem impossible. With its ultra-sensitive sensors, the Webb telescope peers further back in time than any previous telescope. Utilizing red light spectrography, Webb detects very faint light that has shifted significantly into the red spectrum. The first deep image of the universe revealed galaxies from an epoch 13.6 billion years ago. Remarkably, no galaxies were supposed to exist at that time. It all began with the remarkable discovery by Harvard student Rohan Naidu. He and his team announced the finding of Galaxy 13, a galaxy that clearly existed around 200 million years after the presumed Big Bang. This finding suggested, early in the Webb era, that galaxies might have evolved faster and earlier than previously thought. Initially, some researchers were skeptical. Then came GNZ 11, with an estimated age of 13.4 billion years, providing compelling evidence that old theories might be outdated. GNZ 11, one of the most distant known objects in the universe, was originally discovered by the Hubble telescope, but its existence was confirmed by the Webb telescope. GNZ 11 sheds light on early star and galaxy formation in the young universe. Thanks to Webb's exceptionally precise spectrometer analyses, it is now clear that stars and mature galaxies existed much earlier than previously known. Sears 93316 was discovered by the Cosmic Evolution Early Release Science Survey. Initially estimated to be an astounding 13.8 billion years old, this galaxy has generated excitement among some researchers and resistance from others. The discovery of other galaxies allowed for theories of much faster matter evolution, providing a loophole for those committed to the Big Bang. However, a galaxy as old as the Big Bang challenges this view and makes alternative theories, like the eternal universe or Zwicky's tired light, more plausible. The age of Sears 93316 remains hotly debated, with discoverers presenting new evidence to support their claim and critics attempting to refute it. HD1 is another remarkable galaxy, with an estimated age of 13.5 billion years. As one of the most luminous among the very old galaxies discovered so far, it suggests an unusually high rate of star formation. Such findings are crucial for scientists, as HD1 could significantly enhance our understanding of conditions and processes in the universe during this epoch. Now, let's revisit MAX 647JD. Though not among the more obscure newly discovered galaxies, it has intriguing features. Discovered through gravitational lensing with the Hubble Space Telescope and further studied with Webb, MAX 0647JD has an estimated age of 13.3 billion years. While not the oldest galaxy, it is surprisingly evolved. Existing only 500 million years after the Big Bang, it exhibits a level of order and size that suggests it should be several billion years older. This implies its formation would have occurred before the Big Bang, which is impossible. These are just 5 of 15 confirmed impossible galaxies, with more discoveries continually emerging. Tired light, a concept Zwicky proposed 100 years ago, suggests a major oversight in how scientists have studied the universe. According to this theory, light is not constant but becomes tired over time. Even small changes in this fatigue could alter distances by millions of light years, leading to inaccurate measurements. Another aspect of this theory is that light might have behaved differently 13 billion years ago. Consider that the light hitting the Webb telescope's mirrors today was emitted over 13 billion years ago by stars that no longer exist. At that time, Earth and our Sun did not exist, and likely only a small precursor to our galaxy was present. This light traveled vast distances over an incredibly long period. As it traveled, space expanded. If the universe's expansion theory is correct, this could have stretched the light, though this is not confirmed. We cannot measure or investigate the original light directly. We can only study the light that has endured this extensive journey. We could never travel back to the time when the light was originally emitted. Despite these challenges, these faint light signals are truly extraordinary. They allow us to study the universe as it was 13.5 billion years ago, which is incredible. Interpreting these signals involves a bit of guesswork. Researchers use known constants and derive similarities to build our theories and explanations. Besides light, scientists use several other phenomena to measure and describe space. These phenomena are expected to behave consistently. If it turns out that these assumptions were incorrect, we might be facing a complete reorientation of science. Rajendra Gupta, a Canadian researcher, proposed in 2023 that minor modifications to cosmic constants could quickly lead to a significantly older universe. According to Gupta, not only would the age of the cosmos change, but variables related to expansion and origin could also shift dramatically. He presented a coherent calculation suggesting the universe could be 26.7 billion years old, with further adjustments potentially extending its age to 40 billion years. This could simply explain the presence of ancient galaxies in Webb's images. Gupta also revisited Zwicky's ideas, showing that incorporating the concept of tired light could radically alter our understanding of the universe. It's fascinating to see how science responds to these new insights. U.S. astronomer and astrophysicist Michio Kaku is one of those excited by these developments. Known for his books that make complex cosmic mysteries accessible to the public, Kaku enthusiastically explained how the Webb telescope is reshaping scientific understanding. He had long suspected that something was amiss and views these changes as a welcome development. Besides his interest in the visible universe, Kaku is a strong advocate for quantum physics, highlighting ongoing discrepancies between quantum and classical physics as evidence of systemic flaws. Other researchers, such as Webb Telescope project leader John Mather, are holding to traditional theories. Mather stated that he firmly believes the Big Bang occurred 13.8 billion years ago, and that matter, including galaxies, formed faster than previously thought. Another prominent figure in current discussions is Sir Roger Penrose. The British scientist proposed a cyclical universe model where a fundamental matrix transfers the concept of matter from an old universe to a new one. According to this model, information is preserved when an old universe ends, allowing for a form of quasi-turbo recycling in a new universe, leading to faster star and galaxy formation. Penrose's model also emphasizes the role of black holes, suggesting they are the last remaining entities in a universe before collapsing or evaporating rapidly. This collapse marks the beginning of a new universe. In 2023, several research groups in the US provided evidence suggesting that our universe could theoretically have been born within a black hole. Click subscribe now and stay tuned for more exciting videos.